Good morning, my dear students. Welcome in SOM lecture. So now our today's topic is what? Stress. So before this, in last video we saw what is force, what are the types of forces. So after that force, we have stress. So without force, this stress will never develop. The stress going to develop into the material. Yes. So after application of force, yes, those forces you know very well that forces. So all that forces, due to that forces, according to the condition, due to that forces, stress is going to develop into the material. So see, suppose to be assume this is what material. Yes, circular shape of that material. Any kind of material, it may be a plastic, it may be a rubber, it may be a metal or it may be a non-metal. Any kind of metal material is there. So see, supposed to be assume this is a one bar. Yes, this bar having what? Material. Yes, particles. These are the what? Metal particles. Each and every particle attached with each other by chemical bonding. Yes. So when you are applying, supposed to be assumed, when you are applying axial external force, suppose you know what is this force? This is what? Tensile force, because this force moving away from the body. Supposed to be assumed this part is subjected to tensile force, axial tensile force. So what happened due to this tensile force? Yes, length of this part goes increase. This much length goes change. This much length goes change due to application of this external force. So how this length goes change? Yes, due to disturbing this chemical bonding of a material. It means one part moving towards this side and another part, a particle of this material moving toward this side. Why? Yes, because on this material we have applied external force. So due to this application of force, chemical bonding between these particles goes disturbed, and along the force these particles start to move. Are you getting? But when this particle following direction of external force, yes, see, we have some parameter. Yes, so see, we have considered two particles over here, and supposed to be these particles having on an area this. So we have a shape circular, so internal, so because from this end to this end length is uniform, so uniform length is there, so area remains same. So this area is circular, so here also having what? Circular area. So these two particles supposed to be assumed on this area. Okay, so it means these particles having from inside particles, internal particles, these particles from internally of this part. So see, when you are applying force, external force, that time what happen? Increasing in length, this rod goes increase length of this rod goes increase due to application of force. So at that time what happened from internally? Yes, we have, from internal side we have a particles material. Supposed to be these two particle are there. Yes, so these two particle attach with each other by chemical bonding. Yes, so when you are applying force, this particle, one particle on this area moving towards right side, another we have a force over here from external side, so this left side force moving this particle towards left side. So automatically you find these two particles moving away from each other, so length goes change. So but what happened, for period of time these two particles never goes separate if this force is less. If this applied force is less, then these two particles never goes separate, because this particles also has got chemical bonding, and chemical bonding, that chemical bonding has got force. One force of a chemical bonding in between material particle is there. So this internal resistive force, it is called as what? Internal resistive force. Yes, so this internal resistive force between this particle is due to chemical bonding between this particle. So chemical bonding provides strength. That strength provide what? Resistance. Resistance means again force. But these particles having into the metal, that's why this is an internal force, and that internal force is denoted by R. So R is nothing but internal force. But this internal force always opposing to this force, external force. That's why it is called as internal resistive force. Internal resistive force. So R is nothing but internal resistive force, means this internal force, that internal force happened due to chemical bonding between these two particles, and this chemical bonding never losing, I mean, to this internal resistive force. Due to this internal resistive force, why this internal resistive force is there? Due to chemical bonding between these two particles, and this chemical bonding always opposing to external applied force. That's why this R is called as what? Internal resistive force. So this internal resistive force is always opposing to this force. So see, this right side internal resistive force on this particle, yes. So this right side internal resistive force always opposing to what? Left side external applied force. And this internal left side resistive force always opposing to what? External right side force. Listen again. Internal resistive force, you know this internal resistive force on the what? Right side particle, and you know this internal, again this internal resistive force have with us internally on this left side particle, and these two particles chemically bonded. Yes, that is one strength is there, internal side. Yes, so this internal resistive force always opposing to this external force, and this internal resistive force always opposing to this external force. It means right side internal resistive force always opposing to left side external force, and this left side internal resistive force always opposing to right side external force. It means this external force get countered by internal resistive force. It means internal resistive force always opposing to external force. That's why our material having strength, our material never goes fail. Due to this internal resistive force, this internal resistive forces, you know that internal resistive forces always have with us chemical bonding of our particle to particle. Yes, so this strength means internal resistive force always opposing to applied external force. Yes, so see, when first condition, see what happened when external force is equal to internal resistive force. It means internal chemical bonding strength is equal to applied force. So our elongation is there. What? Elongation is happen. If our external applied force is less than internal resistive force, it means internal strength of this chemical bonding of a material is greater than the applied external force, so our part will save, our part will never fail. If, now third condition, if our external force is greater than our internal resistive force of that material, so our part will fail. See my dear students, when external force is greater than internal resistive force, our part goes fail. If our external force is less than our internal resistive force, so our part remains safe. But if our external applied force is equal to internal resistive force, so our part only start to elongate, never goes fail. Only little bit microns, in micron that disturb is there. Okay, so see my dear students, so what is stress? Then what is stress? So you know that stress is happen from inside, because see, this internal resistive force is applied on a material, and material having on area is what? Circular. So on this circular area we have a particles, on that particles having what? Internal resistive force. So see, this internal resistive force, see my students, internal resistive force, see, it means these are the R, internal resistive force per unit area, it's called as stress. Are you getting my dear students? See, because this internal resistive forces goes developed due to application of external force. So this internal resistive forces have on this area. So on this area having internal resistive force, see, so internal resistive force on area, internal resistive force on a area. Internal resistive force on this area. So that phenomenon is called as what? Stress. So internal resistive force. So what is stress? So see, what is stress? Stress means internal resistive force. Force per unit area. So what is stress? So see, my dear students, sometimes the stress is denoted by sigma. So sigma is nothing but internal resistive force means R and area means A. So R per A, and R is nothing but one kind of a force, and that is what? Internal resistive force. Yes, but sometimes what happens, my dear students, this internal resistive force, they people have count is equal to external applied force. So what it become? R replaced by F. So F by A. So what it mean? F for external force and A for area. So external force per unit area. So stress is also called as external force per unit area. External force per unit area, it's called as stress. So we are using in our next chapter definition of the stress in this manner. So what is stress? Stress is equal to force per unit area. And what is unit of this stress? F having unit Newton and A having unit what? Mm square. So this is what unit of stress. So what is unit? F measure in Newton and area measure in mm square. So what is unit? Newton per mm square. So this is what? Stress. So my dear students, we are using the stress force per unit area. And what is unit? Force unit Newton and area unit mm square. So stress is equal to force per area. So keep in your mind, my dear student, this is what? Stress. So now we have types of stresses. So types of stresses are there. So first stress, tensile stress. Second stress, compressive stress. And third stress, shear stress. But my dear students, this shear stress divided into two types. First, single shear stress and double shear stress. So see, these are the types of stresses. So see, tensile stress, compressive stress and shear stress. So see, tensile stress. So what is tensile stress, my dear students? So stress means sigma and tensile T. So T to the base of sigma. So sigma T means tensile stress. T for tensile and stress for sigma. So sigma T is a tensile stress. So tensile stress is denoted by sigma T. And what is stress? Force per unit area. Force per unit area. Yes. So but which force? Tensile force. So FT means T for tensile. So tensile force per unit area. So see, tensile force per unit area, it's called as tensile stress. Are you getting? And what is unit? Again force measured in Newton and again you measure in mm square. So unit remains same, Newton per mm square. Are you getting? Yes. And when tensile stress is produced, see, supposed to be assumed this is a bar. When you are applying tensile force, then this tensile stress will produce into the material. Are you getting? When you are applying tensile force, which force? Tensile force on the part, then into the material, tensile stress is going to produce. Yes. So now see second, compressive stress. Which stress? Compressive stress. So what is compressive stress, my dear students? So see, compressive stress means sigma, and compressive means C. So C base to sigma. So compressive stress. So what is compressive stress? Again, stress means force upon area. So which force? Compressive force. So FC. So FC means compressive force, and A for area. Are you getting? So compressive force. So what is compressive force? What is compressive force? So see, suppose to be assumed this is what part. So compressive force means the forces which are moving towards the body. Then this compressive stress will produce into the material. So forces always acting from external side, and stress always produce into the material. So stress is the internal matter of the part, and force is the external matter of the part. So force applied from external side, and due to that application of force, the stress will produce from internal side. So when tensile stress is produced after application of tensile force, and when compressive stress will produce after application of compressive force. Are you getting, my dear students? And what is unit of compressive stress? Same. Unit of force is what? Unit of force is what? Newton. And unit of area is what? Mm square. So Newton per mm square. So unit remains same. Unit remains same. So stress having unit Newton per mm square. So same unit is here. Newton per mm square. Newton per mm square. So it may be a tensile stress. It may be a compressive stress. Are you getting, my dear students? So these are the what types of stresses: tensile stress and compressive stress. So now what about shear stress? So see, our third type of stress, that is what? Shear stress. And see, my dear students, see, the shear stress is denoted by tau. And again, stress means force upon area. So unit again same, Newton per mm square. So shear stress denoted by tau. Are you getting, my dear students? But what happened? Shear stress. In that shear stress having two type. First is what? Single shear stress. And second one is what, my dear students? Double shear stress. So single shear stress and double shear stress. So see, my dear students, what is the difference between these two? So see, supposed to be assume this is a plate 1 and this is a plate 2, and two plates are overlap with each other. See what happened? And supposed to assume here see, these are the two plates overlapping with each other. So I'm going to join these two plates, overlapping plates, with the help of bolt, nut and bolt. This is what? Nut, and this is what? Bolt. So see, this is what? Bolt. You know this bolt having what? Circular shape. So when you are, this is what? Bolt. So these two overlapping plate I'm going to join with the help of nut and bolt, and this bolt having diameter. See, this bolt, this is a bolt, and this bolt having shape likewise. Are you getting? So this bolt having shape circular. Have you seen that nut and bolt? Yes. So with this bolt, we are going to fit these two overlapping plate. Supposed to be assume from top side we are applying force. On top plate we are applying force, on another plate have with us also on there we are applying what? Force. So what happened? This plate moving towards right side and this plate moving towards right side. So from here you know, from here we'll find failure of this bolt. So this bolt from centrally goes split due to sliding of these two plates by this application of external force. So what happened from here? From this XX, from here this bolt goes fail. This bolt goes fail from this, yes, along this XX. So see how it is. Yes, one part moving towards moving with this plate due to this force, and another part of this bolt moving with this plate due to this force. So bottom side of a hub bolt moving towards left side due to this force, and top side of a part of this bolt moving towards left side due to this force. So these are the what, due to this plates forces from top side and bottom side, these bolts goes fell from this x side from centrally. So see what happened, this area goes fail. Who going to fail in this one? Plate. No, plate never going to fail. Yes, that bolt going to fail. So bottom bolt, half side of the bolt goes into this plate, and top side of a half bolt goes into this plate towards right side. So see, for here we'll find failure here of this bolt. Are you getting or not? So which area goes fail? Yes, only this area. So which area? So see, this is what, circular area. Circular area means D. Circular area means D. Circular area of this bolt goes fail, and circular area, we have to denote by D. So D is a what? Diameter. Yes, and this diameter always measure in mm. Yes. So this shape, circular shape, D diameter of shape goes fail. So what is the area of this circle? Area of the circle is what? Pi by 4 D square. This is what? Area of a circle. And this circle of our bolt, this bolt goes fail in this fashion. Are you getting? So from only this section, only this area, our bolt goes fail. That area is what? Circular area. Circular area means pi by 4 D square. So single time this failure happen into the bolt, because only one bolt is there, that means only one area goes fail, and only one area goes fail means, see, this area put over here. So what happened? So what is shear stress? So shear stress is equal to force upon, due to this two forces on that plate, these forces responsible to fail this area. And which area? Yes, this area. Are you getting? So what is stress? Shear stress is what? Force upon pi by 4 D square. Are you getting, my dear students? Yes. So now what about double shear stress? So double shear stress means, see, supposed to be assume again two plates which are overlapping with each other, and we are going to fit this overlapping plate with the help of two bolt. This is number 1 bolt and this is number 2 bolt. So we are applying external force over here. Yes. So how many bolt is going to fail over here? 2 bolt. This bolt number 1 and bolt number 2 from this XX section. So how many bolt going to fail when you are applying tensile force on these two plates? One plate moving towards right side, another plate moving towards left side. So due to this sliding of this plate, this two bolt goes fail along XX. So 2 bolt fail means 2 area goes fail. 2 area, and both area having a what shape? Circular. So circular means pi by 4 D square. So how many area goes fail over here? 2 bolt are there, so 2 area goes fail. 2 area means, see how the shear stress is depend. Shear stress is nothing but force upon area. So how many area goes fail in this figure? 2 area goes fail, and here only 1 area goes fail because only 1 bolt is here, and here 2 bolt are there. So due to this 2 bolt, 2 area goes fail when moving this plate towards left and right. So again, area of circular is what? D. So what is area of a circular section? Yes, force upon pi by 4 D square. But how many area over here? 2 area. 2 area due to 2 bolt. Because we are fitting this 2 bolt with the help of, we are fitting these 2 plates with the help of 2 bolts. So how many area goes fail? 2 area, because 2 bolt are there. So just multiply by 2. So our shear stress, double shear stress becomes F upon twice A. Are you getting? And what is unit? Force unit always Newton, and area unit always mm square. So unit never goes change. Unit remains same. So these are the what, my dear students, single shear stress and double shear stress. So see, this is a single shear stress, force upon area. But single area is fell over here. Yes, due to this application of external force. But due to this application of external force, 2 bolt goes fail. So that means 2 area goes fail. So 2 area means twice A. So F upon twice A, F upon twice A. So this is what twice means double. So this is what double shear stress, and this is what single shear stress. So see my dear students, in our today's lecture, what we saw what is stress, we saw types of stresses. So see, in next lecture we'll see new topic. So thank you very much.